Today I'll be applying the calculus mean value theorem to prove that for all real values of x and y, that the absolute value of cos of x minus cos of y is at most the absolute value of x minus y. Okay, so in this question we can first analyze a simple case, and a simple case is just when x and y are equal. When x and y are equal, the left hand side will equal cos of x minus cos of x, which is equal to 0, and the right hand side is equal to x minus x, which is also 0. And since left hand side and right hand side are equal, the inequality is true for when x is equal to y. Okay, it turns out there is symmetry between x and y because if we switch x and y around, we still have the identical inequality because of the absolute value signs. This means we can assume without loss of generality. So that's so without loss of generality is the log, which stands for without loss of generality, and assume x is less than y. Or actually, I'll do x is greater than y. So this is the second case when x and y are not equal. Okay, and also make the function f of x equal, f of t equals cosine of t, and the derivative of cosine of t is negative sine of t. Okay, and now let's consider the expression cosine of x minus cosine of y divided by x minus y. So this is quite closely related to the inequality we are trying to prove. So we can actually apply the mean value theorem using this expression. This is because we'll write down the conditions that allow the mean value theorem to be used, which is f of t is continuous on the interval yx, the closed interval yx, because the function cosine is continuous on all of r, and also differentiable on the open interval yx. This means you can find a c in the interval, the open interval yx, such that cosine of x minus cosine of y divided by x minus y is equal to derivative of f of x at c. And this is equal to negative sine of c. Okay, now we'll take the absolute value of both sides, so we can just do absolute value of the numerator divided by the absolute value of denominator is equal to the absolute value of negative sine of c. And since sine of c is going to be between negative 1 and 1, it means the absolute value of negative sine c will be at most 1. And since x and y are not equal, and also the absolute value of x minus y is positive, this means we can bring the absolute value of x minus y over to the other side, and we finally get what we wanted to prove at the beginning, which is cos of x minus cos of y absolute value is at most x minus y. And we can also see, so this is the case when x is greater than y, and due to the symmetry between x and y in this question, the identical proof will work when y is greater than x. So it is sufficient to just show the proof for x greater than y. Okay, so that concludes this proof of the inequality using the mean value theorem. So hope you enjoyed this video. Thanks for watching, and I'll see you next time.